Page 3. The weights of people riding elevator form a population with a mean of 165. Now this is weights of the people, so they can be a nice distribution with a mean of 165. So this is a normal curve with the middle of 165 and a variance. So the mean of the population is 165. The variance is going to be 400. So the standard deviation of the population is 20, the square root of 400. So if I go up one standard deviation, that'd be 185, and next one would be 205. I go down, it would be 145 and 125. So if the elevator has a 5100 load, we'll crash it, pounds. So now, find the probability that 30 people will have a mean that will set this over. So if it's going to cause it to be over that, we're going to put 30 people on the elevator. Then the average weight of that group of 30 has to be, so that would be 5100 divided by 30. The average weight would have to be 170 on there, which is higher than the mean for the population. But then we're looking at a sample mean, which will have a narrow distribution. It will have 165 at the center, and this is the distribution of the means, and it'll have a standard deviation of a sample here. The sampling means, or margin of error, so that would be the population standard deviation, 20, divided by the square root of the size of the sample, which is 30. So 20 divided by the square root of 30 is 3.65. So it'll be 3.65 to this one standard deviation above, so that'll be 168.65, and then another one up, and then I can take it off. But that's how much the standard deviation's here, and we want to know if we can get 170. What's the chances it's 170, which is a little higher here, or above. So we're going to do, we've got to calculate 170 or above. So I could get the z-score if I was using the table by doing 170 minus 165 divided by the standard deviation of this sample, which the means distribution, 3.65. 170 minus 165 is 5, divided by my last answer is 1.3697. So that's the value I would look up on the table for mean distribution or normal distribution. And let's see if I can find a table here to show you that. Yeah, where are my tables? Not there. Not there. Maybe I put it in my drawer here, maybe. Yeah, there's one. So I want 1.37. 1.37 is 0.4147. That would be the probability from 165 to 170, and I want to know what's above that, so I take 0.5 minus that, and I would get 0.0953. Now I should be able to get that with the calculator also. I want to do normal cumulative from a score of 170 and higher, way higher would be like 300 or something big, comma with a mean of 165 and a standard deviation of 3.65, and it says it's 0.0853. Oops. Yeah, 8. Excuse me, I didn't subtract that right. 0.0853. So good thing I did on the calculator to check it. All right. That's 7. Now number 8. A test is given to 16 students on the campus. The scores are given in the table, and these are 16 random students. Find this sample's Tukey 5-number summary and draw the box plot. So I'd have to put these all in order, or I can just use the calculator, and I'll just clear these lists. And put these numbers in: 31, 22, 43, 25, 17, 39, 43, 17, 13, 21, 34, 39, 28, 36, 19, and 20. 1, 2, 3, 4, 5, 6, 7, 8, 16. Yes, 16. Okay, so there's 16 numbers. Stat, calculate the one variable statistics on list 1, and I get my Tukey 5-number summary would be the minimum, which is Q0, which I did incorrectly on the video I did for the last test, chapter 9, but you get it is 13. The first quartile, Q1, or the lower quartile, is 19.5. Again, this is what the calculator does. There's a different formula they use in statistics. Q2, and it's on Excel. The median is 26.5. Q3, or the upper quartile, is 37.5, and Q4, or the max, is 43. Okay, use the empirical rule to estimate the standard deviation. That's the one that deals with the range. So that'd be 43 minus 13 divided by, and since I have 16 numbers, I divide by the square root of n or by 4, which are both the same. Square root of 16 is 4. And I get 43 minus 13 is 30. Divided by 4 is 7.5. That would be an estimation of the standard deviation. Calculate the sample mean. Well, I could just go through and add all these up and then divide by 16, or do the expected value, 31 times 1/16 plus 22 times 1/16 all the way through, and I could do it that way also. And it turns out that the mean is what we had here already, 27.94. All the x's, all these numbers added up according to the calculator says it's 447, and then we divide it by 16, and that's how they came up with, the calculator came up with this for the mean of the sample. And then determine the 95% confidence interval for the mean of the population. So that would be the mean of the sample plus or minus 2 standard deviations, and we don't know the population standard deviation, so we use the sample standard deviation. The estimated is 7.5, so I could put the 7.5 in there, but the sample standard deviation according to the calculator is 10, so I'm going to use that value, divided by the square root of n, and then we had 16, so I've got 20 divided by 4, which is 5. So it'd be 5 added or subtracted from the mean. So 27.94 minus 5 is 22.94. And it's kind of not really necessary to keep that, but that would be my lower boundary. And the mean of the population would be expected 95% of the time to be greater than that, and less than 27.94 plus 5, which is 32.94. Okay, that was 8.